Welcome back to How We Move, where we're breaking down facts about fascia. In this episode, we're diving into the fascinating structure of fascia. Understanding how fascia is layered and what those layers do gives us a powerful lens into how we treat pain, restriction, and movement dysfunction. Let's start at the top. Fascia is a connective tissue system that's structured like a net. It surrounds and supports your muscles, bones, nerves, and organs. Think of it like a 3D spider web that holds everything together. But this spider web also allows movement, communication, and tension distribution. At the microscopic level, fascia is made up of three main components: ground substance, or extracellular matrix, ECM. It gives fascia the gel-like structure. Collagen fibers, which provide structure and tensile strength. And elastin, which adds flexibility. This combination allows fascia to be strong yet adaptable, crucial for providing movement and stability. You can notice in this video demonstrating the loose connective tissue, the columns of fibers providing strength to the tissues and connecting them to each other. We often talk about the layers of fascia. Just under the skin, the superficial fascia is connected to the skin with collagen fibers and located deep to the superficial adipose tissue. Strands of collagen connect it to deeper layers. As well as containing adipose tissue, it envelops many nerves and blood vessels. Involved in sensory processes, this layer is highly innervated and plays a key role in interoception, the body's awareness of its internal state. Superficial fascia is often involved in pain perception and emotional regulation due to its nerve density and the types of nerves that are involved here. We get more in depth about this later in the series. Deep fascia has two components, separated by loose connective tissue. First, the dense, fibrous sheets of collagen called the aponeurotic layer. This layer wraps around groups of muscles like thoracolumbar fascia. It allows for sliding through hyaluronic-rich, loose connective tissue. Within the aponeurotic layer are specialized cells called fasciocytes that produce hyaluronin to support gliding. The combination of these components allows force to be transmitted between muscles and across joints. Deep aponeurotic fascia affects force transmission across multiple muscles and movement coordination. The next layer of deep fascia is the epimysial layer. Adheres directly to muscle fibers and encases individual muscles. This plays a role in local force transmission and the body's awareness of its position, called proprioception. This layer is where fascial restrictions can reduce flexibility or affect local movement patterns. As the muscle fibers contract, they create tension on the fascia surrounding the fibers in this epimysial layer. This in turn affects the aponeurotic layer, allowing groups of muscles to move together and then connect into the superficial layers of fascia. Thanks to fasciocytes, healthy fascia glides easily. When it doesn't, perhaps due to inflammation, dehydration, or injury, layers stick together. This is called densification. It increases friction and alters how nerves respond to mechanical pressure. Manual therapy, targeting fascia, foam rolling, coordinated movement education, or stretching can support gliding by stimulating fluid exchange and affecting hyaluronic viscosity and rehydrating the ECM. Targeting the right layer at the right depth makes a huge difference in outcomes. So why knowing this matters? Because different layers of fascia are associated with different clinical issues. When we understand where the dysfunction lies, we can choose the most effective therapeutic strategy. Here's what we've learned so far. Fascia is layered, responsive, and neurologically active. Superficial fascia is more about sensory information. Deep fascia is more involved with mechanical force transmission. Each layer has unique roles and therapeutic needs. Understanding layers helps us be more precise and effective in dealing with issues. So here's what's next. Coming up, we'll explore how fascia is innervated, diving into the types of nerve endings, what they respond to, and how this connects to outcomes like pain management. If you found this helpful, don't forget to like, subscribe, and share this with another therapist or movement enthusiast. Thanks for watching. See you next episode.